All right, should be live. Let me get. Oh, sorry. That was dumb. I was trying to get my headphones and I hit a key on the keyboard, and apparently it was set to something. Though I think you didn't hear that because I don't think I had that routed. Let's go to a patch that doesn't start playing beats when I hit a key. Okay, give me 1 second. Just switching headphones to ones where I can better hear myself. So, welcome back. I was working. I've been over the weekend and the few days before that. I've been looking into some design issues with the RTC and SMC stuff. Because it turns out it's a little bit more complicated than we expected due to some changes in the M1 Pro and Max. And so I think we have a good idea of what the more future-proof way of doing it is now, and so now I'm going to be working on that. Let's see. I think I have one person watching right now. Hopefully the audio is fine and all that. Yeah, you can't hear that. Okay, cool. So yes, so the first one thing that I've been doing is polishing up the battery and power supply stuff. I just committed that last night. It's not pushed yet. So now it does an extra space there. Now it does more battery properties. Even I got the manufacturer date wrong with a funny thing that I tweeted about that the it needs a fix up due to the firmware having a bug. And then also the logic for determining whether we're charging or not is a bit more fleshed out. In fact, it's better than macOS because it does a thing where macOS will sometimes tell you it's correct. It'll tell you it's not charging when the battery management system is doing like a balancing cycle or something like that. But there's no user visible indication that about why it's not charging, and it's kind of confusing when you have the machine is plugged in and it's not charging. So Linux actually considers in my driver that it considers that state as charging. So even if it's discharging due to internal management reasons, if it could charge and will charge once that cycle is over, and it will show the status as charging so that users aren't confused. So that's that. I also implemented the inhibit charge and force discharge modes, which can be used to implement the optimized battery charging like feature in Linux, same as it works on macOS. Though that's a user space thing. So the kernel just provides the charging disable and force discharge features. One difference with macOS is that macOS uses a version of these features that automatically disables itself at 50% charge for safety reasons. Linux only really has one control, and it doesn't have any implied minimum charge level. So I'm using a mode that actually will, if you set it to force discharge, it will discharge the battery down to 0 even if you're plugged in, and then shut down and reboot. That's mostly because I think some people will want to use this for testing, like discharging and things like that, and it makes sense to expose it like this. But if in the future we decide we want like charge behavior, like some kind of flag where we can force discharge or inhibit charge, but only above a safety factor, that would need probably an API extension to sort of expose it in a way that doesn't remove the ability to actually do a full discharge if that's what you want. So that's that. I also implemented an AC adapter device, mostly just because some user space expects that, and it's handy because it also reports the voltage and current and power limits of the input, so that way you can see how many watts your AC adapter is. And this is sort of a virtual AC adapter that represents whatever the highest power adapter is plugged into the Mac at this time. So it claims to be type mains, even though it's going to be USB. It's technically USB PD in every case because MagSafe is also USB PD. But since this is kind of a virtual device that represents whatever is plugged in, it doesn't make sense to like specify a specific USB port type or something. So there's that. And let's see. Although I could do that. I could make it dynamic. If I really want to, I could try determining what type of USB port is plugged in, but it's probably not worth it. I see a lot of sort of generic AC, like charger devices that report the AC device's mains and, whatever. Um, it also has, I think this wasn't in last time, it has support for the notifications so that it actually notifies user space. So now if you unplug it or plug it back in, your icon changes immediately instead of having to wait for the next post cycle. And that's pretty much it. So this driver is pretty much done. And then, so going back to the RTC, there's been a lot of yak shaving on that, trying to decide what the best way of doing this is. And I kind of ended up changing the design, like completely redoing it compared to how we were thinking of. So there's a PMU that has the RTC. But the thing is, the PMU has a lot of features, right? It has GPIOs, it has all the regulators, it has like measuring like inputs for temperatures and voltages and things. And all of that is actually abstracted out through the SMC. But on the Mac Mini, the OS drives the PMU directly to access the real-time clock. Ever since 12.0, and specifically on the MacBook Pro, the M1 Pro and M1 Max laptops, they don't do that anymore. They access the RTC through SMC, but the SMC only reports the raw RTC timer value. It doesn't let you access the offset. So there is an RTC offset that needs to be added, and we don't have access to that. So that still goes to the PMU. So it's looking like Apple is moving towards abstracting out all of this RTC stuff through the SMC, but they're not quite there yet. The problem is that the SMC in the M1 Pro and Max returns. They have a PMU that's codenamed Maverick. So in Maverick PMUs, it returns the time value in units of clock cycles of 32 kilohertz, which is like the typical clock for an RTC. And this is a little bit important because the offset is also stored in units of clock cycles. While on the Mac Mini, on the Mac Mini, it reports it in units of clock cycles. However, on the M1 Pro and Max, it looks like somehow the RTC doesn't return those low. You read the RTC directly, it doesn't return the full resolution. It only returns a 1 second resolution. But then if you ask the SMC, you actually get the full resolution. So I don't know if it's that the SMC has some other way of reading the RTC that provides the extra resolution, or if it's like synthesizing the extra bits, or I don't know what it's doing. But I do know that macOS uses the SMC to read the RTC on these machines. And that mechanism for reading the RTC is also available now on the Mac Mini. So it seems that Apple is like in the process of transitioning to driving the RTC through SMC. The problem is that originally we were thinking of doing this RTC driver. There was already a prototype and stuff by talking to the PMU directly. But on the M1 Pro and Max, that doesn't work as well because we don't have the extra resolution. And most RTCs only have 1 second resolution, but they also have the behavior where when you write to the RTC, the sub-second counter is reset. And Linux actually uses that to provide NTP time sync that is accurate to sub-seconds. Basically, it'll wait until the second changes, and it'll write the RTC like a few milliseconds before that. And that way you can better synchronize the seconds counter and the RTC with real time. And we can't do that if we don't have access to the current fractional seconds because the offset is written with fractional seconds. Sorry. So even though it's a minor thing and most people wouldn't notice if it clocks off by 1 second, it just didn't feel right. And then, as it became obvious that they added this feature even on the older Macs in 12.0, I'm thinking that possibly the next generation is going to end up using SMC for everything. So in that case, instead of having the clock driver be in the PMU, it makes sense to have the clock driver be in SMC. But we have a problem because we still need to get the offset, and that's still accessible only through the PMU, as silly as that is. They should have just added it to SMC, but they haven't. I assume they will. So what we came up with is this, and this solves a lot of problems, even though it's a completely different way of doing it. The PMU no longer has an RTC driver. Instead, it has an NVMem driver that exports, basically registers in the PMU as non-volatile memory, which is what they are. And in particular, it exports a bunch of things that we need, but one of them is the RTC offset. And using this binding, we can have the actual main RTC driver be in the SMC driver, and then we can have it talk to the RTC driver to actually set the offset. This does mean that setting the alarm would require more NVMe cells, and those are maybe technically not actually just memory, but they might be like proper registers, so it would be of use of the NVMe subsystem. But if Apple is going to move towards using the SMC for everything, which it looks like, then we can just defer alarm support until that happens and just tell people they need to upgrade. So that's if we do it that way, it'll avoid an entire driver that will be obsolete in the near future anyway. And the nice thing about this is that one of the issues we had is that the RTC offsets for all the registers change between the two PMUs that we have. And so there had to be a driver with separate compatibles and a table in the driver and everything. But if we use this NVMe stuff, this is all specified in the device tree. And it also gives us some other nice offsets that we can use. And because the shutdown process has to use some of these flags, and that was also going to coordinate with SMC, this all sort of it changes how everything works, but it makes sense to sort of centralize RTC and shutdown functionality in the SMC driver and just treat the PMU as kind of a, storage device for the settings that we need to change. So I already wrote a generic driver for basically I'm actually submitting these as generic drivers, not even Apple specific, because this PMU is actually a multifunction device inside an SPMI bus, and there's already a generic multifunction I2C device. So I basically just did the same thing and make it generic MFD. And so that it does have an Apple specific compatible, but like the driver is generic. So if any other manufacturer wants to have one of these, they can just add a compatible here, and that's fine. And there's nothing Apple specific here. So that's nice. And then there is a NVMe driver, which is also I also write it as a generic driver because again it's very trivial. It's just exposing registers as NVMe cells. So there's pretty much nothing here that needs to change really. So again, this can be a totally generic driver that other platforms might want to use. Charge counter is less than 0. Sorry, where were we? Charge counter is literally just an accumulator of charge going in and out of the battery. So it doesn't have a defined 0 point. It's basically used for delta measurements over time. So if you read it and then read it a minute later, you'll see how many milliamp hours have flown in and out of the battery in that time. So that's why. It's not a remaining charge counter. It's a charge transfer counter. Delta asked about that. So going back to this, so there's a generic NPM driver, and now what's left is actually implementing the RTC support in the SMC driver, and also adding the shutdown flag support to the shutdown driver. So let's do the shutdown thing first, because that's easier, and we'll sort of prove the concept that this actually works. So actually, give me 1 second. We're gonna get some water because my throat is dry already. Okay, here we go. So let's look at the shutdown thing first. The main thing is that, and also this removes the dependency on the patch set for the shutdown chain handlers that I had previously merged last week, because now all the shutdown is actually going to handle inside the same driver. I'm still going to keep using that because I think it's likely it's going to get merged upstream, and it'd be before this driver gets merged. But if it doesn't get merged, then we can always just change this to use the legacy shutdown stuff and submit it that way, and that's a good thing too, that we have that option. So where was I? Power, reset, Mac SMC reboot. So we have this driver. We need the nvmem stuff. Let me search this, how that is done. If I can get to that. Okay, I need to close some of these windows because my console is hating me because I have like thousands of lines of charge statistics with a search open apparently. And it's really hating me right now. Because it like does some text rendering stuff or something. Can I just scroll back this? Control-Shift-K. Let's just get rid of some of these logs because it really hates that. Yeah, that's better. So, let's go to Linux. Aha. So we have, let's look at one of the drivers, the consumers, but it should be pretty simple. Something like that. So we need nvmem consumer, and we also need to make sure that is actually built. So let's edit the kconfig file. There's a generic nvmem reboot node. That's kind of cool, actually. Because we might even be able to use that, but we probably wouldn't want to. Why is there no... Oh, I guess if nvmem is not built, it will just fail all those requests, probably. So it only depends on OF, which we should already have. Yeah, it has the enode sub story for the for when that's not included, so that's fine. We do not need the dependency there in principle. So oh, cool. So you just pass in the dev and the cell name, and that's it. And you get a car. I guess that's a raw point to the data, and then but there's an SIT data, and then returns red. Yeah, okay. The variable names are weird there, but so that's we should probably do these things in the prepare call, because that should be pretty much right before shutdown, and it makes sense to so It should return a void star, I would hope. Yeah, it's a void star. I don't know who wrote this code with a car star, but that's that is not the type you would use for actual data. But in our case, we're always going to be using small values. So there's an LVMem cell. Actually, let's look at the consumer thing here. Oh, there's a read U8, U16, U32. Cool. Okay, so that's even easier. And let me make sure this actually works with smaller cells. Like, will it typecast? Okay, so it does read common, and then... Okay, so it does expect it to be the full size. What happens with these when the cells have less than 8 bits? It reads the bytes. It does not change the byte length. And then it does a shift in place. Okay, so in that case, because these flags are basically bytes, I should be using the U8 functions, and that should work. I would hope. Okay, let's go with that. So will this do the it should return the reprobe stuff if it's not there. I would hope so. I think it's do I want to use OF or the non-OF version? Probably the non-OF version. I assume that just goes to the OF node or whatever it needs to be. Yeah, it just calls that on the OF node. So that's fine. We can just use nvm cell get. And then it does the device get, and that will return probe defer if it's not there. Yes. When will I make any update blocks soon? I want to get this done first. nvm cell get. Yeah. Okay. So I probably can just do this in the probe instead of here, because that means that if the device is not probed, we want the whole thing to defer. So let's do that. Let's do it that way instead of just in time. And let's call these the same way I did in my... I'm going to do more than one of these cells here anyway. Also, is there a def map version of this? Oh, there's a devm, yeah. nvm device get. Hmm. But that's struct device that just gets a name. That's not quite what I want. Oh, there's a devm. nvm cell put. Why is... Okay. Yeah, but basically this is what we need. All right. So, struct nvm cell, nvm shutdown. Let's look at all the others for T6001. The ones that this driver is going to need are at least NVM shutdown, but honestly, PM settings should be exported somewhere too. And since that isn't directly exported, let's see if we can add that through sysfs or something. That'd be a good thing to test, because I think I've never written a sysfs handler, like a custom one. Then I also want to have the boot stage in here to update that, because that avoids getting error counts listed. Panic count. And then the SMC reference boot stage, boot error count. Let's do panic count too. I guess we don't really need boot error stage. That gets overwritten anyway. That's mostly there just for show. But shutdown flag, yeah. And let's get PM setting in there too. I think that's the power on AC flag. So let's see. Actually, I should test that. Actually, this is kind of this should not be a fatal error, especially for forwards compatibility. Because if we don't have this, then presumably the SMC just knows how to do it itself. Um, but in that case, I definitely need the probe defer thing though. If it's not there at all. So then it wouldn't be dev error probe. I kind of want to make a little array of these, to be honest. I'm not sure if this kind of thing is kosher in kernel coding, but um, it's kind of assuming the layout of this struct is the same as an array of pointers. which should be in the case in like any sane architecture, but um, otherwise I'd have to use like offset off, which is a little bit annoying, and make like an array of all the offsets. Anyway, that's easy enough to change. What do they call that? Is that? I think it's. It's PTR error actually. Yeah, it's negative. I think we don't need the prefix on that. Okay, something like that. It's not a lot of things writing npm. I think pretty much everything except reboot. Reboot mode is like is literally the only driver that writes that. Okay, that's funny. And that's literally what we're implementing here, but there's more stuff around it, which is why it needs to be a separate driver. What exactly does that do? There's a reboot mode register? What does that do? Oh, apparently I have a delivery. 1 second. Hold on a second. Apparently there's a gas thing that, going on, so I'll be right back. Just give me 1 second. Okay, should be back. Sorry about that. Yeah, apparently today was gas leak check day, which I had completely forgotten. But thankfully that didn't take long, though he did try to give me a sales pitch about combining my electric bill and my gas bill and all that stuff, but I'm like, yeah, no, I'm kind of busy now. Okay, cool. Also, what happened to my music? There we go. So I'm trying to figure out if this is something useful. Where does it get the reboot mode from? I think it's reboot into recovery isn't actually useful because we can't do reboot into 1TR for security reasons, because you need to physically press the power button. So that wouldn't actually be useful for us. But I'm just kind of curious as to what this is supposed to actually do. So it just serves a notifier. And it registers a reboot notifier. Was this one of the ones that are touched in the PAT series that I just looked at? No, this is old. So I guess the reboot on Linux does have like a mode string built into it. Okay, fair enough, but not quite what we need. Because this is for shutdown anyway. Uh, Android on Apple Macs. I mean, why not? Once we have the 4K page support, it'll totally work. Yeah, something like that. I actually wonder if we should change the meaning of some of these because I don't think Apple assigns anything particularly special to the ones above 30. Like macOS probably uses it for something. Um, but it might make sense for us to say like mini sets one. Yeah, I mean it would need a PMU driver for that, but it could be kind of cute if we support like mini setting one and U-boot setting another one or something for debugging. But then again, they don't necessarily have to be in order either. So we could say mini and U-boot are like higher up. She might as well put this one here. It is a U8. Something like that. Actually, you know what? I'm going to make this into another function. Because the control flow here is a bit annoying. And then I can error check this without going too far to the right. Something like that. A lot easier to read. And yeah, like I want to have some sysfs attributes for at least the PM setting thing is useful. Boot error count on panic count. I probably should like expose the last boot panic count. I don't know if it might make sense to actually expose the boot stage so user space can like update that, and then for the panic count and boot error count, we could actually leave them and let them increment. So it might make sense to not do the writes here. But I'm not sure. Maybe it makes sense, yeah. But for now, let's let it reset in the driver like this and see what happens. So, and then finally, I want to expose PM setting, and I forgot what the bits for that were. So give me a second. I'm going to actually, I can probably just use the hypervisor and make double sure that that's actually a thing. But on the laptops, it shouldn't matter because they don't. Do they actually have like power on AC attached setting on the laptops? Let me find out. I don't think so. I'm tracing the SMC and PMU. Yeah, sure. I hate that sensor exchange thing or whatever that is. It's slowing everything down. Okay, go away. Yeah, I don't think the laptops have that. The Mac Mini should though. The speakers really hate the yeah, that. It sounds terrible because like the hypervisor is messing with the with macOS's idea of time. It really hates that. There's an AC wake setting here. I wonder if I can change it in the NPM set. Actually, let me just show you because I can SSH into that. Can I SSH into this? Actually, no, I don't have SSH running. Oh, 1 second. PM set AC wake. Okay, that doesn't do anything. Turning that on. That's messing with. It's setting WKTP, but I think it was setting to the same thing. Yeah, it sets WKTP. It reads WKTP. It doesn't write anything. Okay. Yeah, it's not actually doing at least nothing in here. And I am tracing the clock stuff, right? Yeah, it is. It is doing SPMI stuff. Oh, there's auto restart, automatic restart on power loss. Okay. Still doing no writes though. There is a lid wake setting, which these things have on by default, and that should be settable, I would hope. It's still not doing anything. Okay. Oh, sorry. Hey, that's interesting because it's not writing anything. But I know this does this actually work? If I shut down, will it do the lid wake thing? It's turned off now in theory. Or maybe it only stores it like at the end. Maybe it doesn't store it in real time, but it actually maybe it'll write it now or something. So if I close the lid and open the lid, it does still turn on. So I guess that doesn't work. Did it write anything interesting? MX, that's just a sensor exchange thing. Nothing on the SMC. That's the usual MBSC thing. And then all this SPMI stuff, which should be things I already know about. Is display brightness in SMC? That's actually in DCP. So this is writing 6001 with 0, which is boot stage, which I expect. Then it's writing 6003, which is boot air stage, but we don't actually have to do that necessarily. It writes a 0 there. Then it writes F. It puts a 4 there, which is interesting because that's not what I expected. Then it writes an 8. Oh no, that's a read. That's a read command. So it reads and then writes back to it. Set the shutdown flag. And then it messes with 14C0, which is something in the RTC area. I had some of that. Was it here? I have it here. I forgot. Yes. Alarm event. Okay, that kind of makes sense. So that's alarm event. And it does a read, actually, of that. Okay. Then it writes to C, which is the alarm time, I think. Yeah, alarm offset. So that's just setting the alarm thing, which just kind of makes sense. And then C2, it writes to that, and that one was IRQ mask. Okay. Actually write a 0 to that. And then 1401, I thought I had that. That's the alarm control, yeah. So it sets alarm control. Yeah, so it's doing the alarm stuff, which we're not going to support yet. But yeah, I don't know. So I think the lid thing and the AC power loss thing are like not implemented yet properly on these laptops, or like those features don't quite work. But on the Mac Mini, it should. So let me pull up the Mac Mini and just do a quick check to make sure that I know what it's doing. So should be able to boot on the Mini now. So the Mac 13G, I don't remember if it's 12.1 or not. It's probably 1201 that I have on that one. Oh, I don't have a keyboard here. Hold on, let me grab a keyboard. Okay. Also, that didn't work. Oh yeah, I need to fix that. Let me kill that. Oh wow, the micro USB connector on this keyboard is quite destroyed. I hate how these. I used one of these ThinkPad keyboard trackpad things, and I hate how they use micro USB. So flimsy. Uh, this might be a problem. I've been using this upstairs with a different micro USB cable, and clearly hasn't been happy about that. This might not become a mark and replace as the micro USB cable in this thing stream. Except they don't have a good way of streaming that. This might be a problem. I get the feeling this is not going to work. Yeah, no, I think this is dead. Okay, can I just use SSH and PM set and do it that way? Um, shit. And it's going to be one of those where it disabled SSH on update. Excellent. I have a mouse at least. Okay. Why is that not working? That's a normal mouse. You should be working. Or did I just like short out the USB and to go into safety mode on both ports? Let me reboot that. Oh wow, that really glitched up the XNU boot frame buffer. That's weird. I should figure out why that happens. That sounds like we're probably not setting the right depth in the boot args, or it's not getting copied properly. Oh yeah, and I can't enter my password, so that was kind of pointless, isn't it? Do I have another keyboard I can use? I'm not sure I do. Well, this is going to be annoying. At least this works. And also it's slow a sec because of the sensor hub thing. It'd be nice if you had an on-screen keyboard. Do we? Do we have an on-screen keyboard? That sounds like the kind of thing Apple should have. The iMac keyboard is not here right now. Since I wasn't going to use it. It's at a friend's place. Huh. Huh. I don't see an on-screen keyboard. Well, that's great. There's Unicode hex input, which is lovely. I don't think that's going to help me. Huh. I have like Bluetooth keyboards and stuff, but I can't configure that from here. I could try setting up the face dancer again and using the virtual keyboard, but that's going to be annoying. I'll just use my regular computer keyboard. I only have to like type it in once and enable SSH. Just get a USB extender and unplug it through that. There we go. Yeah, see, this kind of restarted due to a problem stuff. It might have something to do with the boot error counts. So, okay, let me turn on SSH first, please. Mini M1 2020. Oh, this is the. It still has the. That's a different. That's one of the installs that doesn't have the proper thing. Okay. Anyway, let me just do what I came here to do. It'll be in the log anyways, so I'm gonna go in here. Is that under energy saver? That's what it's called on these. That one, yes. Turn it on, turn it off. Plug in the keyboard again. Can't reach. Okay, then we get the logs. Actually, let me just do it again now because the mouse still works. Okay, yes, it is right into the PMU there. You can see that. On, off. So what it actually did was a bunch of things, apparently. It reads from 1 and then writes to 1 a 2. And then it reads from 1 and it writes to 1 a 3. So, and the value it read actually is this one, the 08. So it's the LSB is the one that that matters for that. And I think that was PM setting on this one, on Sarah, which is the one, yes, D001, which is what I had, right? Yes, D001. Okay, so that should be enough. Actually, now that I'm on the Mini, let me just test this. So, and actually, I'm kind of curious about the other bits in that register. So if I just kill that, and I have an experiment for writing to SPMI. So it should not do wake up on AC power loss right now. It does not. I have to hit the button. And also the frame buffer thing while I'm here, I think I know what that problem is, maybe. I think it's that I have the frame buffer. That was some stuff that got put in there. The display. I'm pretty sure I messed up setting something here. No, I just set depth to 30. Okay. Oh, is it because No, chain load should still get the right boot args after the chain load. Unless, oh, this was a copy? Oh, because that was a copy, wasn't it? That's why. 'Cause it still has the old, yeah, because it's a copy, that's why. So if I do this, because the way I do the get boot args thing in the proxy is boot args address. That's why. And that's the same thing as this. Yeah. It's a boot args address, so that's why. Then why does chain load work? Does chain load reset that? Probably. Somehow? I'm not sure how that works right now, actually, but whatever. That should fix the string.h. That's so that should let's see, let's go pop the stack. That was a little yak. Actually, I'm just tested that actually did what I expect, just to see that I fixed the screen. Since I'm going to be going back to the M1 Pro later anyway. Yeah, see, okay, now this is actually showing the proper boot thing. Okay, that fixed that. Okay, I can kill that. And let's actually change the PM setting flag from Python just to see that that works as intended. I have some experiments, PMU test. No, not PM manager test. PMU, this one. So let's just copy that. That should be fine, but I need this to be SPMI just like that. If I'm dumping, I'll dump T0, which is where the RTC stuff is, but I'll do 120 on there because there's more interesting stuff there. And then do a try. I might as well test the SMC thing. The RTC offset on this one is at D002. Then it's printing everything at 6000 was one of the scratch part things, which we don't care about right now. But I'm just going to do a write 8 to the PM setting offset, which is D001. Let's just do a read 8 first. Do a write first, and then we can change it. So it shouldn't change anything right now. Yep. And also just checking that this is sane, the counter is sane. Yes, it is. This is what I thought, 5B baby, 5B17. Actually, that's weird. Oh, because this is an yeah. Like that. Yes. Oh. Wait, this is V2. Yes. Yeah, so it started with E, then it somehow nailed the what? Okay, that was dumb luck. It completely nailed the seconds there, and then the SMC read actually returns the same thing a bit later. So it's a few milliseconds later. Yeah, okay. So this means my plan for the RTC is consistent on the Mac Mini. And the PM setting is 3 right now, which is interesting because that was the one that didn't wake up, so it's inverted. Let me double check. Kill it. Yeah, it's definitely not booting on power loss right now. Okay, just checking some messages. So let's clear that bit. Should be clear now. Yes. That still didn't work. Okay. Wait, did it? Oh, it is. It's working. It's just not doing the boot chime. Interesting. So an AC power loss, it doesn't do the boot chime? Huh. I guess that kind of makes sense. Because otherwise you'd have like a whole room of Macs going dong at the exact same time when you have a power outage. They probably did that on purpose. I also wonder where the boot chime setting is. That's another setting that we haven't looked at. The laptop should have that one. So I can look it up on the M1 Pro and hopefully it's in the same place on the other one. Okay, so that's interesting. So 2 means wake up on AC power loss. Three means don't do that. And I wonder if that other bit does anything interesting. If I set it to 1, will the GPU driver support Vulkan natively? At some point. Okay, so 1 does not power on automatically. Seems to just work normally. And what if I set it to 0? Then it also doesn't power on automatically. Okay. Yeah, so 2 is wake up on AC power loss, but like silently. Three just does it normally. Just double checking. 1 is manual. And yeah, 0 also is not automatic. So that's interesting. The 2 bits somehow have a related meaning there. I wonder what they do. Do any other bits do anything interesting? If I set it to like, should be FE should be equivalent to 2 with everything else set. That did power on automatically. And FF. Yeah, it just behaves the same. So really 2 and 3 seem to be the values we care about. How's the engine my keyboard? I don't have one. This is a Japanese keyboard. I mean, I can type one. But okay. So yeah, I'm not sure if there's any other interesting bits in here that we might care about. The question is whether I want to set up the NVRAM ranges as PM setting or as like individual bits. But given that the top bit seems to be necessary for the wake up on AC power loss thing to work as intended, I think I should just have the whole byte in there. We'll see. And also, let's see what it does on the M1 Pro. So I'm curious now. Don't need that anymore. I like this on the right side. What kind of mechanical keyboard do I use? Everyone asks that question. It's Philco keyboard with Cherry MX Brown switches. All right, so let me do the regular PMU, and on that one, PM setting is in 1405. PMU. That is interesting. Oh, I didn't print it. I'm dumb. Okay, that's a 2 on this one, which is wake up on AC. And if I set that to 3, and let's do the shutdown. Close the lid. Open the lid. That does boot. But the question is, will it boot when I plug in the charger? Also, did that stick? It did stick. Let's do a shutdown. Not on the charger. Does it normally do that? Apparently not. Oh, it does. Okay, so if I unplug all of the connectors and then give it power, by default it does. If I set it to 3, will it inhibit that? So now there's nothing plugged into it. Okay, so it does work. It is possible to make it not turn on AC power attached on the laptops, even though macOS doesn't give you that setting. So the wake up on AC power attached is also a thing on laptops. Oh wait, no, now it turned on. The second time I attached it. Well, that's annoying. Maybe it only happens sometimes. Yeah, no, it still does it. I think I was just lucky last time. So let's try 0, see if that changes the lid state or anything. That does turn on lid. And just try EFF for good measure. Yeah, that still turns on when the lid is open. There is probably a setting for this somewhere, but it's not this one. So PM setting only makes sense on the desktops. But I don't know if there's a way of knowing that. The PM setting is still here. Yeah, I'll have to figure that out. But for now, I guess for the for the time being, I'm just going to treat it as a single flag, an 8-bit flag that I mess around with in MacSMC Power, and we'll just go with that. Sorry, MacSMC Reboot. I'm also not sure if that's actually restart on AC power loss or restart on AC power period. Like I don't know if it's keep the last. That could explain the differences on the Mac Mini because I was always testing. Yeah, it's like, is it always gonna? I would have to implement shutdown on the Mac Mini for that to work, which I can. Okay, let me do that test before I write this. So let me just make another shutdown. Actually, let's just make it generic for fuck's sake. It's kind of dumb that I'm not doing that. And I should actually move that PMU thing to a proper. Also, we don't know what that is. I'm gonna get rid of that. Shutdown. That should be a saner way of doing it. Let's see if it actually works. Uh, I wonder where the boot chime setting is. I can check it on the M1 Pro. The info leg. Oh. It always... Nah. Damn it. Because they use underscores in that one. I need a hack for that. Let's say 2 underscores is an actual underscore. I'm not a fan of that. I need a struct in there. Okay, there we go. That did actually power down. And it's still off. And the other one is the PM setting. Wait, that actually shut down. That's interesting. That actually shut down without doing the SMC call to actually shut down. Okay. Well, that's interesting. What is doing the shutdown? Oh. Oh, I get it. This makes the LED turn off. It's not actually shutting down. If I do this, it's still up. And a reboot makes it come back. Oh, that's cute. Okay, so now we know what that thing does. That turns the LED off on these machines and probably does other things like that. Does it have a timeout? I think it didn't on the... I don't think it has a timeout. Or at least not a short one anyway. Otherwise it would be dying. But if I press the power button at that point... Okay, I actually get the notifications. Yeah. Oh, it did actually. I think it just shut down. Or at least it stopped responding to button presses. Is it down? No, it's still there. It just stopped responding to button presses. Oh, because it filled the buffer. I think I didn't act something, probably. Okay, now it powered down. Also, endpoint 2? Oh, that's syslog. Okay, yeah. The syslog because the notifications aren't enabled. So those are the log messages. Okay. So this should actually shut down now. Yes. That's kind of evil, though. It means that technically the LED can turn off and the thing is still on. So PM setting 2 should be the regular restart on AC power. Whoa, what just happened? That was booting for a second. It is dead. Okay. Look it back in. And it doesn't turn on. Okay, so that is actually restart on AC power loss, strictly speaking, not restart on AC power applied. Yeah, because it is actually turning on if I kill the AC power while it's running. Okay, so another question is there another setting that will allow it? Maybe that's what 0 does. Let's see. The problem is that it's actually hard to test this because the capacitors and the power supply are going to be running for quite a while the thing is shut down. So I don't know if I can actually... Yeah, not turning on, but... Waiting a few seconds. I think it's actually dead now. And it's definitely not turning on AC applied. Okay, let's try 1. Nope, still not turning on AC applied. And also not turning on AC power loss. So okay. That one should do it, but not on shutdown. Hold on. It did do it now, but it might be because I unplugged it too quickly. Okay, no, it didn't turn on this time. Three should be the default power on 3 power on AC power loss. If I do a shutdown, wait a few seconds. Wait a few more seconds. Yep, no power on. No power on applied. That's what I wanted to say. Zero. I just confused myself with the applied loss one. 3 is definitely neither of them, which makes sense. Otherwise, I would disable. 2 should be power on AC loss, but not applied. So let's just say, let's do it like this. I'm basically testing applied right now. That's what I'm doing. So wait a few seconds. Nothing on applied. Try 1 again because I confused myself there. And I'll do all the lost ones later, but it should be the same. Those should be easy anyway. The lost ones are just unplugging it. Because I don't have to wait. Nope, still nothing there. Check 2 again. Nope, nothing on applied. And now 2 should do on loss, so we're not going to shut down this time. Oh, actually, I think this might be putting it into a mode where it considers it. No, that's not working now, huh? Wasn't 2 supposed to wake up on AC power loss? Oh, is it this flag? If I set that 8, it probably actually does a shutdown. No, okay, this time it did power on. Let's not do that anyway. Yeah, it is powering on now. Okay, try 3. That is not powering on this time. Try 1. That is not waking up on loss. That is also not waking up on loss. So I guess 2 is the only one that works on loss, which is interesting. Wait, I didn't write 0, did I? Okay, but that is in fact not waking up on loss. Okay. That is waking up on loss. And now let's try the other flags, see if there's anything else interesting there. Like Let's try FE. FE does wake up on loss. I don't know what that one, but it is plus loss. What about applied? Okay, that did not do anything on applied. And I assume FF will be neither, so probably the top bits are unused. Yep, definitely didn't power on AC applied there. And if I don't do the shutdown, it didn't do either. Yep. So really, it's just it's a bit weird that 0 doesn't do anything though. Okay, I wonder what the bits mean here really. Because it's like it has to be 2 for the wake up on loss to work. But it's like the bottom bit is like inhibit somehow. But then why does 0 not work? Then it's like it also needs the top bit somehow. Yep, I don't know. But yeah, I guess in that case the driver just has to do 2 and 3. And we don't have any particular as the Mac different powers like regular current and USB-C. No, this one just has the Mac Mini just has one main power supply. It doesn't power off of USB-C. And the laptops, well, I was testing that earlier and I didn't get any response out of that flag. So well, it's possible Apple might add support for that in a newer firmware revision of the PMU. So the PM setting should be a hardware thing because the firmware isn't running when the thing is dead, so I'm not sure. So the other thing I'm curious about is the boot chime. Where is that stored? Is it NVRAM or is it? It's probably actually NVRAM. Yeah, it's probably NVRAM. I don't think it would be in the PMU. So anyway, given that PM setting, in that case, it probably makes sense to just not have that flag exposed at all on the laptops if it doesn't do anything. So, which means I shouldn't actually have this here, but that also means that yeah, the power on lid open stuff is probably based on like interrupts or something. So the other thing, let me just look at the boot chime thing real quick. And I need that one. Where was I? SMC. Mac SMC reboot. Okay, so actually, what it really should be is AC loss store. Not really AC loss. AC. And we don't really have anything else, but that's a better way of saying it. Okay. Yeah, I'm getting your computer was restarted because of a problem story. If I click report, it says associated report detected iBoot panic, but I think that's a lie. Because I'm not changing the boot stage, right? So that's the thing, is that you get those error messages if you don't reset the boot stage counters and stuff. So let's try building that, see if I get the boot stage stuff, and I can use that to not... Actually, what happens if I just do a hard shutdown here? And then run macOS again? Am I going to get the that error message? So at that point, it would be just a macOS like hard shutdown. Oh, you can't use flexible array members and unions, huh? Well, okay. That's slow. Okay, so I get nothing if I just do a hard reboot. If I do that though, if I boot into mini and then just reboot again, and then run macOS. I should just turn off the SMC tracer. It slows everything down so much. Oh no, I don't get anything. Okay, so I don't know where the iBoot panic came from then. Maybe it was something I did that caused it to panic on the next reboot. Not sure. Anyway, so I was going to look for the boot chime thing, which I'm pretty sure is going to be an NVRAM, but let's just test. Okay, too slow. Yep, that is definitely NVRAM or something. It's not. And just to check. Oh, actually, I'm not seeing any NVRAM changes when that happens. Oh, sorry. Yes. Startup mute. It's an NVRAM setting. So yeah, nothing to do with the SMC driver in that case. Hmm. And that's the alarm setting I just turned on then. Oh, and ESN. That's interesting. I wonder what that is. Also, it just rebooted? Oh, did it just crash? Oh, it just panicked. Well, that's fine. What did it panic on? Huh? The AMCC thing? Well, okay. That's that was that cache thing. Oh, is it because mini maps? No, it doesn't though. Well, that is a very weird crash to have. And it was just in. It was just waiting. I wasn't doing anything. Huh. But yeah, I'm guessing NESN and LGP have to do with panic logs. Ugh. Yeah. Pan B. And then pan E. Pan beginning, pan end. Which I can tell because... Yeah, it does an IO platform panic catch on Apple SMC. And then it does another IO platform panic catch at the end, including Apple SMC. And it does a watchdog thing. Interesting. It'd be really cool if we can get like Linux panic logs into the SMC and then like it reboots into macOS and you get the Linux panic in the macOS window. That should totally be possible, by the way. But I'm not sure where the panic logs get stored right now. There's this SOCD thing in the PMU, but I'm not sure if that's what it is or how it works. But at least it should get a panic log now. What am I working on? I'm working on the SMC power and RTC driver, and I'm just kind of tying some loose ends that I wasn't sure about yet. Yes, it actually got the panic. So I'm not 100% sure, but I think the way the panic stuff is actually supposed to work is that it writes the panics to some like scratch RAM or something in the SOC, and then on reboot, iBoot will write it to like persistent storage or something like that. But the PMU does have that SOCD thing, which is kind of curious. So I wonder what that's about. Okay, well, that's everything I need, I think, for now. Now, the PM setting thing. So the shutdown should just work with this. Let's see if it does. I need to finish this, make sure it builds. Let's actually do a restart from macOS. A proper clean restart. We're not using that. Oh, this just goes straight to device, not even. Okay. Oh, okay. The cell ones. So that just does lookup directly. And that returns error pointers. That's a little bit annoying. So it reads I guess I can just make my own helper for this. It's a little bit annoying, but at least I can then make it return. But those need to be U8s. Like that. Oh, that's the problem. Boot stage. Yeah, we don't need that. And then do the air clowns here. Just do init error counts. Hmm. Oh, that. You do need red. Okay. And let's try running this. So hopefully shutdown support works now. And let's see if I get the error counts too, if they're somewhere. All the MDM cells are missing. Well, that's not good. Let's try that again. Is mine to Enoent? Probably. Yeah, Enoent. So why is that missing? The drivers are loaded. Oh, I know why. Because this is looking in pdev. No, it should be pdev. Oh no, because we don't have an OF node. We need an OF node for that. Yeah, that's why. And it's the same thing I did for GPIO to make that stuff work. And also, I want this one, not the full Art Linux. Okay. I need OF on this now. And also I percent D on line 215. That always along. It is along, yes, apparently. Fair enough. And in this case, we have MacSMC reboot. PMU log 2 boot errors and 0 panics. That makes sense. So let's do a reboot. So reboot obviously works. Hopefully it won't log any boot errors this time. Yep, nothing there. GPIO, reboot. Failed to write boot stage. That's interesting. Oh, well, first of all, I should be using the U8 thing for those anyway, but oh, was that just a straight semicolon somewhere? think I was just missing the less than 0 there. So it should log 1 boot error now because I didn't do a clean shutdown. Yep, 1 boot errors and 0 panics. Yep. And now a clean reboot should log none of that. Yep, nothing there. And now is shutdown going to work? It did. It works. Cool. And did I get the logs in here? Yes, I did. Look at that. No, sorry. This one. Yep. It writes to that. Actually, wait. It did what? 6001 8? Then wrote in 0. But yeah, okay. So it clears the boot stage and then it writes an 8 to that. Yep. And did a read from that too, I think, right? From F, yeah. So it does a read, which returns a 0. And then it sets that bit because it's a single bit flag, so that makes sense. Cool. Okay, so that is that taken care of, and now I just need to add a syscontrol for that AC power loss thing. Which makes sense. Flag PM setting. Okay, so how do I do syscontrols? I've forgotten how to do that. Drivers. Let's just go look some power stuff. Should be easy enough. SysFS, sorry, not syscontrol. Yep. Mhm. This one. That's what I need. What should I call this parameter? AC power mode. AC powered mode, maybe? Yeah. AC power mode. And it should be verbose, so same thing they're doing here with the modes. Oh, there's got to be a helper for this that is. There's got to be a helper for this that does this for me. Like choosing one of n. We already have other people working on drivers for things. It's not just me. Like my job is to do whatever nobody else is doing, basically. Um, Surely someone has written something for this. What's the example this one had? Yeah, the scheduler, right? So that's not a device attribute. Should be a string for that somewhere. That one. Has the same logic. Come on. I guess nobody has I guess no one has unified this yet. Yep, same damn logic. Okay then. And device attribute has to go after that anyway. I'm going to need to set driver data on that, right? Yep. Where'd my MFD go? SMC under server platform. Apple SMC core. This dev set drive data, but this should be platform though. Okay, get the reboot, get the driver data from dev parent. No, this should just be dev. store buffers stn. It is size T. Do I think there will be drastic changes in the next Apple processor? No, because they never make drastic changes. They already made some preliminary changes with the M1 Pro and Max to support bigger systems, so I expect even more things to work. In fact, part of the way I'm designing this is so that there's actually some chance it might work and boot on a newer machine even without any kernel updates. At least to a frame buffer. Graphics driver will definitely need to be different for each device, though. Okay. And then we create the attribute thing. Do I need to remove files? Apparently I do. Is there a devm create device create file? That'd be handy. Nope. Why are like obvious things like that not in devm? Debugfs has it apparently. Well, okay. I guess I need a remove call now. Something recent. Yeah, they just get called in device remove file. Wait, no. It doesn't clean up path. Or is that just a device that can never be removed? Oh, okay. I guess that's a device that can never be removed then. What about that spy one? Yep, it just goes on that. Well, okay. That should just be a platform device. Everything else should be devm'd So I don't think we need to do any other cleanup anyway. We're just to double check. Nah, that all looks reasonable. Okay. Any warnings? Nope. Okay, let's see if the AC power loss thing. Well, it's gonna show up on the. Actually, yeah, that's a good thing. I think to mention the we could just not have that NVMe still on machines that don't have that feature. But anyway, might as well just run it on here and see what happens. You should do the writes anyway. Oh yeah, it's shut down. But my reboot command still works even when it's shut down. Excellent. Okay. Cool. SMC reboot. No weird messages. Is there actually a class for this? MISC? No. It might just not be a class for this. But it's not a is it power supply? No, because power supply is the actual supply, is the battery stuff, not the reboot handler. No, I think there's no class for this. Where is that? Oh, bus. It'll be in the bus. Yeah, it'll have that at least. But yeah, I guess there's no actual like shorthand for it. Okay. AC power mode off restore, and it's probably because I set it to a funny value the first time. Yeah, it was at FB, which is FB. Oh, okay. So something cleared that next bit. Interesting, because I was messing with that earlier, but something cleared bit 4. Okay. That seems to be doing the right thing anyway. That puts a 2 in there. That puts 3 in there. Yep, it should work on the Mac Mini. Okay. I'm not even going to test it on the Mac Mini right now because I'm pretty sure that's going to work. And now the RTC is the other missing driver here. But I know what I'm going to do. And it's more of the same NVMe stuff anyway, so it's just going to be copy-pasted it. I kind of want to do the boot stage stuff, but it would be nice to have the error counts in sysfs. But we can do that later. That's not totally required right now. The AC power mode, though, is nice to be able to change because there's no way to change that if you don't have macOS. So, why is NVMe involved here? Because I think you might be thinking of a different NVMe. NVMe is the subsystem for storing, like, think CMOS on PCs, like little bits of information. you're probably thinking of like NV DIMMs or something like that, which is a different story. And yeah, actually, this is not even general non-volatile memory. It's kind of abusing this because I think this is an actual hardware register. I think. But we're using other parts that are actually non-volatile memory, like the boot error count and those are definitely non-volatile memory, like a generic NVMe area. This AC power mode one is a little bit of a hack. But like if we don't do it, there's a good chance the new machine is going to put this in SMC anyway, and if we don't do it here, then we need like per device PMU drivers, and it's kind of sad. EFI boot entries. No, on EFI is actually stored on a different thing. The EFI parameters would be stored on EFI non-volatile storage, which is a different kind of like the EFI variable storage is actually stored in Flash. NVMe is more for like RAM and fuses, and actually there's like a single driver that writes to NVMe, I think. So it's mostly intended for fuses, but it works for this use case. So clock driver. Time to create a new driver. Let me kill this so I can reboot faster later. Drivers RTC, and let me just copy the power reboot reset Apple. Or is that Mac SMC? Yeah. RTC Mac SMC dot C. Pick make file. That was the one that was the previous experiment, which is now going to go away. Wow, one that is actually sorted properly. Not Mac PMU, Mac SMC. What am I doing? SMC. Oh, but these aren't sorted, are they? Yay. TC driver. Are they vaguely sorted? MT. No, they aren't. Why is there hardware mon support? Okay, those are just subflags. GameCube RTC. Yay. Is there any reasonable place to put this? IPMT R S. No, this is like totally random, isn't it? How did that end up there though? Like between because someone copied that one and that's why it ended up there. I guess it's going at the end then. Because I should have these in here. I'm not sure what the rule for those arch things. Like we've been doing default for Arch Apple so that it doesn't like gate all the drivers, but yeah, this is enable support. But like I normally interpret that to be adding support for that, not gating everything on here. Yep, RTC real-time clock. I'll ask around. That's how people want that done later anyway. But because we have a bunch of a bunch of depends Arch Apple. Oh, we do have it on depends on these apparently. We're kind of all over the place here. We have some depends and some not depends. Oh, we use both depends and default. Well, that one has that, the NCO one. But what about the see, that one just has depends, right? No, so we're doing both. Oh, we're probably doing both for SOC and stuff. Okay, that makes sense. So let's just do both then. Okay, so let's do that one. Mac SMC, RTC driver. We need pretty much everything here and the RTC thing, so I can copy some of this RTC stuff from here. Don't need reboot. I think we need everything else. What's delay doing here? Oh, I do have that in restart, yeah. Okay. Don't need that. And in this case, we only need one for now, so we're not going to do that. And we don't need these handlers because the offset is actually a bit more involved in this. Okay, so I'm going to just leave the probe function in here. And now for the SMC keys that we need, it's basically going to need the clock M1, which is the raw RTC value. And I think in the future they're going to start using clock U probably, because that's listed in microseconds. But since the offset, at least so far, is in ticks, we're going to go with that. So this one is fatal. Okay, now to steal some stuff from the other RTC code. No, that uses RTC for the dev data, but in this case, that's not a good idea for this one. Where is it? No, we should do the... Oh yeah, RTC is RTC, right? RTC, yeah, this is what I want. Okay, get some of that. RTC, range max. Why did I have 31 in there? Because it's seconds? Yeah, because it's seconds, right? And it's a 48-bit counter, so. So some get time and set time goodness here. RTC class ops. And this will be Mac SMC RTC. And there we go. So we get the counter and then we write the offset. So now is I need that's a 6-byte value. Is this a thing? That'd be convenient. Oh, it is a thing. Excellent. Yep, that's exactly what I want. Okay. And now I just get the counter. It should be SMC read. Not this header file, that header file. I am returning the that on reads, I think, in SMC core ticket. Read key, yeah, return ret, which is supposed to be oh no, that just returns. It does get SMC size on command ret on reads. Yeah. And then the nvmem read, which is the same thing there. From the reboot support. something like that. Okay, that's pretty much how that should work. And then for set time, the read is going to be the same. Yeah, I think that'll work. Don't need the remove call. That's going to give me, yeah, that. With the PMU. Oh, yeah, that. Does this new approach use SPMI or can the RTC offset redirect directly? It still uses SPMI for the RTC offset, but it abstracts that out through the NVMem framework. But I'm getting the feeling that Apple is going to move that into SMC in the future. So then we'll still have to change the driver to not use SPMI, but then those will not use SPMI. Don't need that anymore. And now it's also dead. It's not RTC shift. Sec shift. Yeah, hopefully cheaper in the future. Is it firmware change? You mean the Oh, I think it'll be a firmware change because they already did that. They already added what I'm using here. This clock M property apparently showed up in 12.0, and macOS does not use it on the Mac Mini. They started using it on the M1 Pro and Max, but it exists on the Mac Mini, so we can do it this way. So I think I'm kind of hoping that they will introduce it with the next generation, and then like it'll be backported to that version, like macOS 13, basically. But that's a guess. I don't know exactly what they're going to do. A lot of this is kind of like guessing what Apple might do and try to do things in a way that will work best with that. So let's see if that works. How long do you figure Apple will keep changing things like this? I mean, they always change things, but the thing is, they usually change things in a way that's backwards compatible. And in fact, changing to SMC, like the old way still works on the. That's like macOS still uses the old way on the newer firmware, right? And in fact, the firmware has to be backwards compatible because otherwise macOS versions would stop working. So it's not going to break on like nothing should break ever, pretty much, on existing machines. The way like we're doing the whole firmware thing, like by design. Now, whether we need to change the drivers for new machines or not, that just kind of depends on, you know, on how they change things. But for example, moving this to SMC will mean that in the future we probably never have to change this code ever again for any future machine. So Apple is moving in the direction of making more of their platform forwards compatible, and they actually have a like they're like the vendor that does that the most. This is much better than all the other embedded ARM like platforms. That is a wrong date. But I think I know what happened. Or maybe not. SMC reboot. API. Oh, do I have the cell in the SMC driver? Don't. That would be why. It read the clock. And it panicked. Yay. Also, where'd that boot error come from? Because oh, it read because it was checking for key exists. Yeah, key info. And oh, I forgot to add the RTC. So that wouldn't work. But why did I get another pointer DRF? Let's see. Yeah, it doesn't. It's not built on debug mode. 120, but RTC is allocated, right? Yeah. And this driver data should definitely be there because that's the only thing that makes any sense. Oh, RTC div. I didn't allocate that. That's the problem. That would do it. The kernel GPU driver is being reverse engineered right now. So you have fire on the job, and I'm going to get helping on that if I can. Like once basically all these little nits I have left to wrap up are done, which should be pretty soon. Okay, let's get that in there. That looks like the right date. 9:37. Yes, that is the right date and time. Cool. Can I change it? Set to not set. I guess it only copies on this one. To be productive like me, I don't know. Okay, let me set this to 2021 01 01. It's dots apparently. Dash 001 02. And let's write. Yep. So let's first reboot, see if that still comes back, which it better should. And the question is macOS going to show that too? Well, it has NTP, so probably it will update at some point, but let's see if I can see it at least. Yep, that looks about right. And then let's try macOS. Display brightness is in the display controller. Let's just stop that. Yeah, look at that date. 0920, because this is UTC plus 9. Wait, did I get that right? It already updated the time, by the way. But 9/2/20, did I get that right? It should be UTC plus 9. And I set it to, what did I set it to again? Yeah, 00 UTC, yes, correct. Cool. So it does work. Is the GPU driver going to work well? Is the driver going to work well enough to use it every day, like basically stuff? I mean, that's the goal, right? That's the whole point. That's the reason why we're doing this. I think the user space driver is already passing like 90% of OpenGL ES 2.0. Like, or more than that, even like 95. So once the kernel driver is done, that will like automatically work. Cool. So RTC works. Excellent. That's finally something that was long coming. And I think this way of doing it makes a lot of sense. Also, all the drivers are pretty small. There's nothing complicated going on. And this works for every PMU. So Let me add a bunch of things because yes, exactly. Joey says commit a sub. That's exactly what I'm doing. What did I change in RT-Kit? Oh, yeah, I need to fix those. A plus and C. Those should be IO mems. Mm. Uh, Calling that platform Apple SMC. That can go away. Anything interesting there? Yes. I need the simple stuff in that. Do I understand why I have to explicitly list the MFD cells in the code? Because it is not using compatibles. That is not using a bus under MFD. It's just using like an explicit add cells, which is fine in this case because we are. By the way, I actually need to do it like that because I intend for this driver to work on non-OF systems, in particular on T2 Max. And so the subdrivers are actually designed to like gracefully fall back and not probe if that feature is not present in the SMC. The only thing is that right now everything I've done with SMC so far is M1 exclusive. But in particular, once I add hardware monitoring, I think that's and fan control and all that should be the same on Intel Max. That's also why I have to set the OF node manually in the drivers, because it's not actually tied to the to OF. It's PMI, sorry. Not that one. Actually, not PMU. Sorry, that is going to go away. But this one is coming in. This one. How did we end up with Oh, a rename ended up here. I'll fix that up later. Let me also add, I think I don't have the SMC stuff in here yet. Let me also add it to this one. Yeah. It should be the same. Probably, that. I'll have to clean this up, this commit later, but that needs to go away. That comment is garbage. Training white space. Didn't I add that? Oh, I had it here or under CPUfreq? No. I thought I added the straight. Yeah. Anyway, SMC RTC. Oh, it is working. Okay, it's just that was leftover, I guess. Oh yeah, I think it's one of those things where the yeah, I don't care about that. Oh, still have the scratch pad and vmin thing there. RTC Apple PMU module name. Yeah, you're right. Where is that? RTC. Da da da. Hmm. Hmm. Is it? Where? Oh, in description. Yeah, you're right. In the cake config, right? That one. Do that. Where did this come from? Yeah, the cleanups. Yeah, it's that one. Okay. Yep, and all this stuff is going to go away. There. So I probably should do a big rebase and fix up of things at some point, but not quite there yet. But maybe at least on top of this. A lot of these can be fix-ups. These can go on the RT kit thing. The mailbox one should be before that. And the SMC one can just have the fixes for those. Support for events and SMC key exists. Sure, I don't get any conflicts yet. Okay. Okay, and we're gonna get rid of this Sarah PMU driver because we don't do that. Design Apple Sock CPU. Nope. Sarah over SPMI. Not that one. That's not there. That's not there. That one can just go into the SMC thing. And I think we can pretty much just get rid of all these commits. It'll be a merge conflict and the one on the end there, and we can live with that. Something happened. Deleted and... Oh, yeah, because that was the one with the rename, right? Yep. And this should be called nub SP0. Amend it and rename it. Okay, that looks reasonable. And I should also clean these things up. Do I want to just do the CPUfreq work on top of this, or give me 1 second? Give me 1 second. Okay, I'm gonna go to the toilet and And I'll be right back. And then I can look at CPUfreq. Though I'm getting kind of hungry, so I'm wondering, we'll see. We'll see how I do this. Okay, let's see. So, and also this is SPMI work, although it's kind of now SMC work plus SPMI. um, let's see, 1 second. Drivers, CPUfreq. There's a lot of them. Let's get a simple one. Oh, well, I need one that uses OPPs, though. This kind of thing, I guess. But not the big little switcher. Yeah, so I want to use the CPUfreq DT support. Let's oh, sorry, the DT stuff I can't use. That's what I was using previously, but this is using the clock node, right? Yeah. Oh, this is a short one that claims to use OPPs. Oh, this is closed regulators. Yeah, this just says the clock set rate stuff. This might be a reasonable one for that. Mm-mm-mm. And let's look at a more complicated one. Like, SCMI looks more complicated. Oh, it's not that bad. TI. This has like all the fuse stuff. But the actual PP code. Tables. Yeah, it just has a lot of random crap. It's not that bad. Okay, let me just open up a few of these files. CMI S. Where's the other one? CPI. I can use these as a reference. Apple cluster CPUfreq, I guess. Apple, like Apple Silicon CPUfreq. Nah. Let's go to Apple cluster CPUfreq. Another one vaguely in the right order, but not quite. Oh, this is sorted by files. Okay. Maybe Apple Sock CPUfreq might be a better name. Yeah, because that was a new file. And that actually it should be number 1. Ah. Oh, how does that work? That one depends on CPUfreq DT, but how does that work? Oh, because that's the not the actual generic driver. That's the like OPP stuff, I think. Oh yeah, the plat dev is the actual, yeah. No, this is the device though. Wait, it shouldn't need that. Everything is like in a different format. Does it even have? None of them have the module text on them. Kernel configs are so like all over the place. Okay, so let's see how complicated this is. First of all, let me get the branch out. Ah. Um. Uh. Okay, that is there. Before I get going, next me what needs a rewrite. Because when I submitted this for upstream, there was a comment that said that maybe this shouldn't be a clock driver if it isn't really a clock provider, which kind of makes sense. Because I originally implemented it as a clock provider so that then I could use the existing device tree CPUfreq support. But that's kind of it's a bit weird because it's not really a clock provider. So yeah, I mean, I'll send this one and see what they say basically. But also there are some issues with the way we were handling the memory controller performance controls, and I'm not sure how I want to do that yet. I might keep the old memory GenPD stuff, so I might keep that part the same. So the new approach is just doing a CPUfreq driver like directly. Ah. And I need the I should fix that license thing somewhere. Keep forgetting how that is specified. Like that. Uh, there. Look at CPI was an easy one. And we need an OF match table for this too. But the annoying thing is, yeah, because this driver now is going to handle. This is one of the reasons why I did it the other way as a clock driver, because that way I can have multiple clock providers for different CPUs. But there can only be one CPUfreq driver. So then this driver needs to handle all the clusters at the same time, which is a little bit annoying. Unless I handle it as an MFD, but that'd be a bit weird. Um, oh, there's more than one CPUfreq on this one? Oh no, they're just in different files. Uh, yeah, see, so there's only one driver here, right? And then it has the CPUfreq domain thing that gets added to the CPUs, which I really don't like. But it might be the only way of doing it. I mean, the thing is, like, this is how Qualcomm does it, and they are not known for doing things the right way. But this is kind of what I'm going for effectively. So let's do this in T6001, and this is in oh, I forgot where those things are. I think it's the same as on the Mini, actually. Yeah, except it was these 210E. Yeah, it's actually the smallest. It's actually the first thing in the address space. Is that a thing? It's a Qualcomm thing. Okay. So I definitely use the CPU map thing anyway. Oh, that's weird. They have different frequency domains within the same cluster. Huh. Actually, I don't need these OPP things there, probably. How does Qualcomm do it? They do have it. Hmm. Wait, yes, I think they are supposed to be like that. Is this gonna work? Would it? That's probably gonna fail. Yeah. Mm, mm, mm. I'll fix those later, but for now, just dumping stuff in there. I think the OPPs are the same for M1 Pro Max, but I should check because they might not be. Um, let's see what the M1 Pro ADT says. Oh, these aren't decoded right now. Oh, that's the GPU though. There we go. That's what I wanted. Okay, they do set them as shared. Oh, because they are actually 3 different types of clusters. Yeah. But then they do have different frequency domains, if I remember correctly. Oh, no, they are... That one is the same, actually. Hmm. So it's actually slightly different here. It's we don't really need the microvolt information anyway, because that was kind of that's kind of gratuitous that I included it, but probably shouldn't have it in there. And then I need like the states. It's the same, right? 828, 1056. Yeah, this is the 3228. Or not. Ooh, did that change? Huh, did the clocks change? For the Firestorm? 600, 828, 1056, 1296. Ah, okay. Interesting. Is the box the same? It looks like it. Interesting. Either I got it wrong in the first time, or they actually I didn't realize that it had different frequencies. Okay, that's interesting. So I guess M1 Pro Max are clocked slightly, ever so slightly higher than M1. Interesting. Okay. Or maybe just the curve was kind of different because the last one isn't that different, but yeah, there's like the levels where they chose are kind of different. Okay. I'm gonna iterate microvolts because honestly we don't need that and it's kind of pointless. The latencies I can remeasure later, but they should be roughly in the ballpark. It might be faster for these because they have the CLVRs. Yeah, let me just run the test. It is indeed 3228. Yeah. So for the ice storm, it's yeah, it looks about right. And together it's 22. It's a bit more actually. Let's call that 23 and 29, 40 and 50. That looks about right. And for the peak cluster, that one is max 8 or so. Yeah. And then we have just round up to 1000. 19 225. Yeah. 24. Let's go to 28. 2208 is 44 apparently. And then again, see if it gets any better. That's about the same. Okay, 45. 2448. 53. 56. Apparently that's lower somehow. Let's just go both 56. Yeah, I think it's 56 for everything after this. After 2904, it's pretty much 56. And do I want to do the OPP? I don't want to do this just yet. And those are correct, right? 2064, 10, yeah, those are the same. Those did not change. Okay. So, 2919, where? Oh, here, yeah, you're right. Okay. Ta-da. Honestly, I just kind of want to make the driver look at the CPU map table and figure out the maps from that and not have a custom property like Qualcomm does. Hey, where did CPUfreq stuff go? Oh, I stashed it. That's what it was. Yeah. And just kill that. No, that's not it. How do I... Ah, that. That's what I wanted. No, not abort, because abort will, like, revert the changes. That's not what I wanted to do. Stash apply. Yeah, it's annoying. I already added that. It's just this the only thing I needed anyway. This kind of makes sense, because then I can call the reg names the same as the clusters and look up the same things in the CPU map, and then, yeah, I think that makes some sense. So let's see if I can do it like that. And then we'll have to figure out something about the memory controller stuff, which is a bit weirder. Like I did this power domains thing here. That's what that is, but yeah. Let's see if I can get the regular CPUfreq stuff doing today, and then I'll probably leave the memory controller stuff for another time. What did I call it? Yeah, that. Well, you don't need those. Just use the main compatible. CPUfreq. CPI, okay. And these are platform devices, which is, but I guess we do need those. Okay, so let's do these like that. So this is mostly going to be the same. I just need the sharing CPU stuff. And that might be enough code copying that I should be making this DPL only, but honestly, that's fine. Because this is a very Linux thing anyway, so. Oh, is this one for each? I need to add this to the block list because otherwise it'll load the other driver. Um, oh, what? This is the core compat. Oh, that's annoying. Then we need that thing. Good thing I added that. Hmm. Is there a link to OPP from here? Not quite. Aha, there's a driver data thing. Oh, I see how it's doing that. Does this use driver data anywhere? I don't think so. Okay, so what I should do is um what I should do is stuff that in driver data. Actually, you can just use break base for that pretty much. Okay, something like that. No, because that goes through clocks. Yeah, that's not gonna work though. Okay, so now is there a way of getting some driver data stuff in the policy maybe? There's a driver data in the policy, yes. Which is, but that's per CPU though. Well, I can just point to that in the main driver in that. But the question is, there's a CPUfreq get driver data. Yeah, that's what I need. Okay, so set the reg base on here. And this becomes very easy because we just have to ta-ta. Okay. And then I need to map those things. Is this a thing somewhere? Do I want to use a CPU map or do I not want to use a CPU map? Or do I want to do it the Qualcomm way and have a... I have a thing in there that maps to the other thing. I'm a bit concerned about nesting. If we end up having CPU map nest in the future, that could be trouble. If I just like hard code it like that. But if I start putting properties in here, it's going to be really annoying to find them, even if it's nested. Okay, let's see how Qualcomm does it. What is that one called? Qualcomm CPUfreq hardware. Yeah, that one. It's just a big driver. Uh, Also, we should probably implement this fast switch thing. Yeah, basically this. I guess we'll do it like Qualcomm does. Yeah. I guess I don't really need this. I can just look it up in the clusters and do the remap there, probably. But I do need a devm or something at least. I can. Hmm. hmm. How are we doing those? Because platform, I don't need the platform because it's not a pdev. I do need the div, yeah. Um, I can just use the driver data though, I guess. And this uses is error for that, so okay. Okay, something like that might actually work. And then I just need to set the I might not even need that actually. It's just for the devm stuff. Yeah, I can just do my own freeing. Hmm. Okay. Let's see if this is getting somewhere. 449. Huh? Oh, the SPMI thing. Yeah, that got reverted. And this needs to go away. We'll add that later. Ooh. RTC offset. I thought I added the SMC to this. Oh, sorry, I mean the SPMI. Oh, no, the SPMI isn't added yet. Let's just comment that out for now. Did I not add this to kconfig? I didn't? Oh, because I was in the stash too, right? That. That's going to do that. Oh, actually, I need Okay, let's see how bad this is. I need an include for CPUfreq on that. CPU mask too, and CPU for that matter. Freak table. This is policy freak table. just use red for that. Oh yeah, I need a name for that. I think the OPPs thing has to happen same way it would here. Huh? Nice. It actually has a static name. Great. Uh, I need fast switching here. Okay, it builds. Let's see if it runs. It's going to explode very badly. Hold on. Something just went very wrong there. Okay, let's see. Definitely not CPUfreq. What happened there? Failed to get sharing CPU mask. Oh, because I forgot that. Indeed. That needs to go in there. Failed to mark OPPs as shared. I'm getting there, though. Probably because it doesn't have OPPs, because I think this needs to get them from somewhere else. How does the Qualcomm thing do it? I think it needs a, not the PMSC, the CPUfreq. Are they actually also doing that get resource stuff? that. That got as far as trying to change the rate, so that's good. And what happened there? Oh god, fast switch tried to do a print K. And now we're in oh, that's why. Because that print K ended up in console print. That's why. Just get rid of the debugs. Okay, that boots. That's the CPUfreq folder. Okay, there's 3 policies. That's looking good. That's a bit weird. Ugh. Okay, so it is going there. Okay, so it does work. Interesting that it ends up putting 2 CPUs into a higher P state. What was that called? Oh, trace P manager probably. Nope. That should definitely do it though. Yes. Aha, okay, it's because the task set was running on another CPU. So yeah. So let's burn some CPU, and now that one goes to full power. And if I task set this to 0, to 1, sorry. Yep, it goes to that one. If I task set this to, what is it, like a CPU 16 or something like that. I think that's still... Yeah, there we go. Looks like it's working. Yeah, I meant 2 clusters. But yeah, it's because the task set itself was running another CPU and the shell, and so then that was causing another one to go up. Interesting, and it actually does it like it increases it like slowly, which is kind of cool. I guess because I implemented fast switching, which is something I couldn't do with the previous design because it wouldn't be able to run from intra context. So that actually is kind of nice. Okay, that looks like it's working. $6,300,000. Yeah, that's the like crazy result for Drystone. For some reason, the P cores are like way faster than the E cores at this benchmark. Yep, looks good. Yep, it's doing that one all right. Yeah, that's more like it, performance-wise. The P cores will be about twice as fast, including the the CPU frequency difference, which is about 1.5. So that all makes sense. CPU system device system U0 CPUfreq schedutil. Those do show up. Now if I do this again, it's going to be hella slow, as expected. Yep. CPU 2. And set power save on here. Task set to CPU 2. It's a bit faster, but still slow. If I set it to one of the other ones, it's still fast. Yeah, okay. I'm pretty sure this is working. So I think I'm going to say that is it for today. I'm going to commit what I have. So I learned my lesson last time. Why is this modified? Oh yeah, because of that. Is that? There's a fix up. A lot of the details later. CPUfreq. I'll clean that up later because I still have some more stuff to do. I need to work on the. I need to do the memory controller trick. There's a thing where when the CPUs go into higher P states, when the P cores go into higher P states, the way what macOS does is that it changes the memory controller timing parameters to make it a little bit faster. In practice, that has a very tiny impact. I couldn't really find a benchmark where it made a significant difference, but we should probably do it too. So I'll work on that later. And I need to fix these things up with the SPMI. And I'll fix the commented out thing later. Okay, I think that's enough for today. I'm pretty hungry, and I should be getting some dinner. And so see you all next time. Someone asked about proc CPU info. You'll better reboot it, but I can show you before I leave. Am I remoting into a Mac when doing this? Kind of. It's a hypervisor that is running from the machine that I'm running on to remotely control the target device. So I'm kind of remoting into a Mac through USB, if that makes sense. Yeah, there you go. That's CPU info. All right, see you all next time. Bye. No, we don't have that. Yep.